In the last lesson, I worked out or demonstrated where the formulas for angle addition came from for sine and cosine. In this lesson, we're going to use those formulas in order to work out exact solutions for angles other than the standard angles 30, 45, 60 degrees, or pi over 6, pi over 3, pi over 2, and pi over 4. So let's without further ado, let's go ahead and get to it. Let's say I want to find the sine of 75 degrees. Okay. The first trick is to recognize that this can either be the sum or difference of some known angles. In this case, I'm going to break this up into the sine of 45 degrees plus 30 degrees. Both of those are well-known reference angles. Okay? And so according to the rule for addition of sine, it is sine 45 cosine 30 plus cosine 45 sine 30. Now you may have it sine, cosine, or the order may be different, but it's just you take the sine and cosine of both angles, and then you take the cosine and sine of the other angles switched. Okay, that's the nature of it. Okay, so using the unit circle, I'm not going to go into incredible detail demonstrating the unit circle. That's for another lesson. Sine 45 is root 2 over 2. Cosine 30 is root 3 over 3. Root 3 over 2, sorry. Plus cosine 45, that's root 2 over 2. Times sine of 30, that's 1/2. Okay. So multiply straight across. Root 2 times root 3 is root 6. 2 times 2 is 4. Root 2 times 1 is root 2. 2 times 2 is 4. We have a common denominator. Therefore, sine of 75 degrees in exact form is root 2 plus root 6 over 4. Okay? We can verify this. Let me pull up Desmos here real quick. That's a great thing to do, by the way, when you do a problem. We can evaluate square root 2 plus square root 6, all divided by 4. And we can evaluate sine 75. Now, mind you, Desmos defaults to radians, and we're working in degrees here, so make sure it's set to degrees. And look at that. We get an exact, as exact as Desmos can, answer. Now realize that any decimal answer is going to be irrational. Square roots are by nature irrational. And so there is no such thing as an exact decimal answer. Just very precise. All right, so that's how to use sines. Let's do another one here. Give you a further example. Let's find the cosine. Let's go with radians here. Pi over 12. Cosine pi over 12. Now in this case, I'm going to use subtraction, but really the lesson gave you different formulas for addition and subtraction. It's easiest. I find my memory is a limited commodity. It's something that I need to take carefully, and so it's easier to remember the addition formulas and just think of it as adding a negative, right? And then use the addition formulas with a negative, rather than memorizing another formula for subtraction. Okay, and I'll demonstrate here. Okay, so this happens to be cosine pi over 3 minus pi over 4. You can check. 4 minus 3 is 1. 3 times 4 is 12. That's pi over 12. So cosine pi over 3 minus pi over 4. All right, so let's evaluate this. Think of this as pi over 3 plus negative pi over 4. Now the double angle, or the angle addition for cosine is cosine cosine minus sine sine. Cosine pi over 3. Cosine negative pi over 4 minus sine pi over 3 sine pi over 4. Okay, and keeping in mind the unit circle, cosine of pi over 3 is root 3 over, cosine of pi over 3, which corresponds to 60 degrees, is 1/2. Cosine of negative pi over 4, that's down in the fourth quadrant here, that is going to be positive root 2 over 2, because cosine is positive in the first and fourth quadrants, minus sine pi over 3. Sine of pi over 3, sine of 60 degrees is the height, root 3 over 2. Okay, sine of pi over 4. Sine of pi over 4 is root 2 over 2. Okay, and sine of pi over 4, and sine of negative pi over 4. Almost made a mistake here. Sine of negative pi over 4. Sine of negative pi over 4 down in the fourth quadrant is negative root 2 over 2. Okay, so we have a negative times a negative, which is a positive. So this is root 2 over 4 plus root 6 over 4. And so this turns out to be root 6, or root 2 plus root 6 over 4. Interesting that it turns out to be the same as our previous one. Okay, root 2 plus root 6 over 4. Let's verify that. This is cosine pi over 12. Cosine pi over 12. So cosine pi over 12. Now remember, we're in degrees at the moment, so click the wrench tool and change to radians. Okay, and then square root 2 plus, got to get out from under the square root 6, all divided by 4, and they are exactly the same, so we verified it. Okay, now the tangent and the cotangent formulas can also be used. I find it useful to memorize the tangent formula, not as useful to memorize the cotangent formula, since the cotangent formula is just the reciprocal of the tangent formula, and so forth and so on. And same with secant and cosecant. So at least memorize sine, cosine, and tangent. All right, so I'm going to leave it at that for now, and leave it for you to learn the formulas and use them.